So in the previous video, we talked about a little bit about angles, some trigonometry basics, and in this video, we're going to talk about coterminal angles, radians, and degrees. What exactly is a coterminal angle? Well, let me give you first an example of what that might look like. We said that if I had the x and the y-axis, so here's my x and here's my y, this is 0 degrees, this is 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So something that I would recommend is try to at least know these quadrantal angles that are on the quadrants, like in the middle of the quadrants. Try to memorize these. So if I were to, for example, let me pick a color. If I were to have, so remember, here is our initial point. And basically an angle is if I were to rotate this whole thing all the way, all this line segment, so this segment, if I were to just rotate it all the way till I get to this point, okay? So this entire movement, this entire rotation gives me an angle. So in this case, what would be this angle? So this angle for the purple, okay, the angle, and I'm going to write theta, is going to be 180 degrees because I went over 180 degrees that way, okay? Now let's say, for example, we have another angle. Let me call this, I don't know, blue. Okay, so I still start from my initial position. I rotate it. I go past that, go one full revolution, and then I go all the way here. Okay, what is that going to be? Well, basically, notice that it's in the same position as 180. So it's not 180 because what I did is that I went one full revolution. So it's 360 plus this 180. So what I'm basically doing is I'm taking 180 and I'm adding 360 degrees to it. And that's going to give me 540 degrees. Okay? So notice that these two angles are in the same position, but they have different measure. So what we call these, we call them coterminal. So 180 degrees and 540 degrees are coterminal angles. Okay, so basically what that means is that they have the same initial side and terminal side. Okay, that's what a coterminal angle is. Okay, so how do you find coterminal angles? Okay, so how do you find them? All you have to do is add or subtract an angle by 360 degrees. That's how you find them. Okay, so let's do some examples. So let's say here is my axis and I want to figure out what this angle is going to be. Okay, tell me what that angle is, and also tell me what this angle is. Let me choose a different color, maybe pink. So what would those angles be? Okay, so for this one, this purple one, notice that this just goes all the way to 90 degrees. Okay, so basically this theta is just going to be 90 degrees, and that's it, because it only went from 0 all the way to 90. Okay, now what is this angle going to be? Well, notice that this is always pointing at the 90-degree angle. Okay, but notice that to 90 degrees, I added a whole revolution. So this angle is going to be 90 plus 360 degrees. So if you put this in your calculator, if you do 90 plus 360, you're just going to get 450. Okay. Let's do another example. Find two coterminal angles for theta equals 170 degrees. Okay. Okay, so what should you do? Well, 170 degrees, you don't really need to graph it, but just so that you can kind of think about it. So here's 0, 90, 180, 270, and then 360. Okay, well, 170, if you wanted to kind of figure out where exactly 170 degrees is, it's going to be around here, really, really close to 180. Okay, so we want to find two coterminal angles for theta equals 170 degrees. Well, how do you find them? Well, all you have to do is just, from this angle, why don't we just add 360 degrees? So we're going to take 170, add it to 360 degrees. Okay, so take 170 plus 360, you're going to get 530 degrees. Okay, so if I add 160, 360, you're going to get 530. That's a coterminal angle. How do you find another one? Well, another one, what you can do many different ways. You can take 530, which is the same position as this one, and then just add another 360 if you want to. So 530 plus 360, that's going to give me 890 degrees. Okay, or something else that you could have done, you could have taken 170 and subtracted 360. Okay, so basically what you're doing is that you're now going the opposite direction. Okay, so if I take 170 and I subtract it by 360, oops, I'm going to get negative 190 degrees. Okay, so basically, if this is my initial position, I'm going all the way here. Okay, so you could add, subtract positive 360 or negative 360, and you will still get a coterminal angle, whether you're going clockwise or counterclockwise. Okay, now usually degrees are really nice. In engineering, you use degrees a lot, but in calculus, because we are in calculus, we use radians. We don't really use a lot of degrees most of the time. So in calculus, we use a degree measure called, or a measure called radians. Okay, and what exactly is radians? Okay, so basically this is what a radian is. So an angle of x radians is an angle that cuts off an arc of length x on a circle of radius 1 centered at the vertex, or at the origin if you want to call it that. Okay, so that's basically what a radian is. So an angle of x radians is an angle that cuts off an arc of length x on a circle of radius 1 centered at the vertex. So what exactly does that mean? So if I were to have maybe this circle, okay, so let's say that you have this circle, and it's a circle of radius 1. So let's just say here's my center, and it's a circle of radius 1. So that means it's 1 at every single direction. Okay, so 1 radian is basically what this is. So a radian, okay, so let's say let's say this is 2 radians. Okay, so how do you know that's 2 radians? Well, if this is 2 radians, that means that this arc, the length of this particular arc, this guy right here, is also 2. Okay, so that means if this is 2, if the inside of this angle right here is 2, that means that this arc is also equal to 2. So if this arc is 2, then this angle is 2. Maybe I should say it that way. Okay, so the length of the arc is 2, then the angle measure is also 2. Okay, so that's basically what a radian is. So once this thing is equal to this thing, then that is what it's going to, that's basically what a radian is. Okay, so how can we classify radians to degrees? Well, if you think about the arc, the length of this arc, well, if I were to take the length of the whole arc, we're basically calling the circle, trying to figure out the circumference of the circle. The circumference from geometry is c is equal to 2 pi r. Okay, in this case, since the radius is 1, we can say that the circumference of the circle is going to be 2 pi. Okay, so that means one full revolution, right? The whole length of this whole thing is actually 2 pi. Okay, so also in degree world, we know that one full revolution, okay, is also equal to 360 degrees, which tells us that 360 degrees is equal to 2 pi radians. Okay. This is our conversion. And I can actually make it a little bit easier. If I divide by 2 to both sides, I get that 180 degrees is equal to pi radians. Okay, so this is basically our conversion factor. Okay, so how we convert from degrees all the way to radians. So let's just do a couple of examples on converting radians to degrees. Okay, so here's my example. Convert to radians. Okay, so let's say you want to figure out what is 90 degrees in terms of radians. Okay, well, 90 degrees, I'm going to write 90 degrees right here. Whoops, what did I do? Okay, so here's 90 degrees. Well, what do we know? Well, we know that there's 2 pi radians for 360 degrees. Okay, so if you think about it, the degrees are going to cancel each other out. Okay, if you think about it that way. And then what you're going to have is 180 pi over 360. And what this gives me is pi over 2 radians. Now, typically, we don't write radians. We just write pi over 2. And we don't need to write this rad if you don't want to. It's just supposed to be thought, oh, this is pi over 2. If it's something in pi and we know we're talking about angles, this is going to be radians. Now, notice that we could have used 180 over pi because then you're going to have a factor of 2 and then it will be easier to reduce. So you can use 360 equals 2 pi radians, or you could have just used 180 degrees equals pi radians. Okay, so which I think is a little easier. Okay, so 120 degrees. So what is 120 degrees in radians? Okay, so I'm going to have 120 degrees. I know that in the bottom, 180 degrees is equal to pi radians. So basically what I'm doing is I'm using this guy, okay? Using this guy. You could use the other one if you want, but I think pi over 180 is a little bit easier. So you're going to have 120 pi over 180, which is going to be equal to 2 pi over 3. I would want you to reduce this as much as you can. You can use your calculator to reduce it, but please reduce it to its lowest forms. Do not give me the decimals, so no decimals. Give it to me in terms of pi. Okay? All right, now let's do one more. So let's say you want to do negative 60 degrees. Okay? So how do you convert that to radians? So you're going to have negative 60 degrees. Okay? So you know that in 180 degrees, you're going to have pi radians. Going to get rid of that. You're going to get negative 60 pi over 180. And that's going to give me negative pi over 3. Okay? So that's how you do that one. Okay? Now, notice that you can also convert to degrees. So convert to degrees. So let's say, for example, we want to know what pi over 4 is. Okay? So this is in radians. How do you convert to degrees? Well, we have pi over 4. Okay? We want to convert this to degrees. Okay? So we know that in pi radians, you now have 180 degrees. Okay? So the pi's are going to cancel each other out. You're just going to have 180 divided by 4. This is going to give me 45 degrees. Okay? And then lastly, what you can do, part B, maybe what is 7 pi over 3 in terms of degrees? Well, you're going to do the same exact thing. 7 pi over 3. You're going to put the pi on the bottom, pi radians, in 180 degrees. The pi's are going to cancel each other out. So then when you put this in your calculator, 7 times 180 okay, and divide this by 3, you're going to get 420 degrees. Okay, so basically the rule of thumb is that if you want to convert from radians, from degrees to radians, so let's just write it here, degrees to radians. Okay, so if you want to convert that by 2 degrees to radians, then basically what you're doing is you're multiplying it by pi over 180. Okay, as you can see here, I just been multiplying it by pi over 180. And if you want to convert from radians 2 degrees, what you have to do is multiply by 180 over pi. That's basically the conversion factor. So if this helps, hopefully you will be able to figure it out instead of figuring out what units cancel what.